Imagine a telescope so powerful that it can look billions of years back in time, peering through the cosmos and revealing secrets of the universe we've never seen before. Well, that is the James Webb Space Telescope, a revolutionary satellite designed to answer some of the most profound questions in modern astronomy. The James Webb Telescope is a space lookout station launched by NASA on December 25th, 2021 in the French Guiana. It is designed to look further into the universe than ever before, using infrared light to see through the dust and gas clouds. JWST will help scientists study the formation of stars, galaxies, and planets, as well as search for signs of life on distant planets like Mars. It is considered one of the most advanced space telescopes ever built.
The James Webb Telescope is a giant telescope to understand the universe and the origin of the universe. This telescope examines basically all the important events such as the Big Bang Theory. It is also an active mission that arrived in L2 on January 24, 2022. The James Webb Telescope helps scientists explore the space by detecting infrared light after its December 2021 launch. Unlike the Hubble James Webb Telescope, the advanced ability to penetrate cosmic dust enables the telescope to uncover new galaxies formed close to the Big Bang era. Its scientific equipment stays cool when the sun shield blocks incoming heat of size of a tennis court. The James Webb Telescope will help us study exoplanets better while also learning about how stars form and when life appeared in our universe. Thanks to its advanced technologies, this instrument will help us understand the key aspects of our cosmic environment.
Why don't we look at the incredible technology that makes the James Webb Space Telescope possible? At the heart of this telescope, it carries one of the largest mirrors ever developed, a 6.5 meter primary mirror. This mirror is made up of 16 hexagonal, gold-plated beryllium mirror segments. The reasoning behind the beryllium mirror segments is because they are light and can do the same job as any other material could. The mirror collects light from distant objects, giving JWST photos an unprecedented level of detail. Furthermore, the mirror of James Webb will be one of the most complex spacecraft systems ever launched, and takes an expert team, lots of development, and tons of testing to prepare the mirror of the James Webb for launch and operation at Lagrange Point 2. The mirror alone took 14 stops at 11 different places in the US to complete the manufacturing, starting in beryllium mines in Utah before being moved across the country for processing and polishing. Since it's an infrared telescope, its mirrors and sensors need to be kept at extremely cold temperatures to detect faint heat signals. The sun shield protects the telescope from outside light and heat sources, as well as from heat emitted by the observatory itself. JWST's sun shield is the size of a tennis court and protects the telescope from the sun's heat, keeping it cool. There are 5 layers of the sun shield that reflect the sun's emissions and keeps the inside around negative 233 degrees Celsius, while the outside stays around 85 degrees Celsius. NASA states, this is essential to maintaining proper alignment of the primary mirror segments as the telescope changes its orientation to the sun. JWST is equipped with 4 powerful instruments, NIR-CAM, MIRI, NIR-SPEC, and FGS. Each of these is designed for a specific scientific purpose. The NIR-CAM captures near-infrared images of distant galaxies and stars. The MIRI observes cooler objects in the universe, like distant galaxies and star-forming regions. The NIR-SPEC analyzes the composition and movement of distant objects. Lastly, the FGS helps keep the telescope pointed accurately and studies exoplanets. There were a few design flaws to the James Webb Space Telescope. Compared to the Hubble Space Telescope, the mirrors couldn't be cleaned once it was sent into space. That's another reason why they used gold beryllium mirror segments instead of regular ones. Another challenge with the mirror was designing one that could fold up for launch, then unfold perfectly in space. It took years of engineering to make sure that the space telescope's huge components could deploy correctly once in space.
One of its main goals is to study the early universe. The Webb telescope will be the premier observatory of the next decade, serving thousands of astronomers worldwide. It will study every phase in the history of our universe, ranging from the first luminous glows after the Big Bang to the formation of solar systems capable of supporting life on planets like Earth to the evolution of our own solar system. The next focus is on supermassive black holes, which are believed to be essential to the formation and expansion of galaxies. And using JWST's advanced imaging capabilities, scientists will be able to study how black holes affect the evolution of galaxies, affecting their shape and development. Finally, the James Webb Space Telescope will conduct a thorough investigation of star formation. It will look through cosmic dust and locations where young stars are currently developing to demonstrate how stars and planetary systems are generated.
Location is an important factor in gathering images from space. Since the Hubble Space Telescope orbits Earth, it's limited to how far it can observe space. Meanwhile, the JWST orbits the Sun, providing clear views of the universe. Compared to the visible and ultraviolet light used in the Hubble Space Telescope, the James Webb Space Telescope uses infrared light.
The JWST is composed to make significant contributions to our understanding of dark matter. Discoveries will also have intense suggestions for understanding dark energy. By studying the most distant galaxies and observing the expansion of the universe, the JWST would help scientists dive deeper into studying the universe than ever before. In conclusion, the James Webb Telescope is more than just a telescope. It is a powerful tool that will change our understanding of the universe, revealing secrets about its past, present, and our future. This telescope will also help us continue to make advanced technology, just like the JWST, to help us dive deeper into astronomy.